Okay, this is the rest of Section 9.2's homework. Section 9.2. We're on page 130, and I'm finishing up. I already posted numbers 8 and 9, and now I'm going to post 10 through 17. Okay, so number 10 says, without using a calculator, find the end behavior and x and y intercepts. Okay, so first of all, the end behavior needs to be decided by the degree of this polynomial. So you count your x's. There's 1, 2, 3, 4, 5 x's. So this leading term will be x to the fifth. Since there are 1's in front of all of these, it's like a 1x to the fifth. So it's going to be positive. So that means your ends will be as x goes to the right, y goes up. But on the other side, on the left-hand side, the y will go down. So whenever it is odd, one hand's going to go up. I always do it like this. Thumb, fingers, 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 fingers. One will be up. Thumb, 1, 2, 3. Okay, that's not a great hand. So your ends will look like that for all odds. Okay, positive, left, down. Now, if there was a negative 1 in front, this hand would be up and this hand would be down. So this one's positive infinity, and this one's going to go negative infinity for your y's. Okay, now what are the x-intercepts? Well, basically, you take each factor here and set it equal to 0. Like you would set x plus 4 equal to 0. So one of your zeros is negative 4. That's an x-intercept. Now, you don't really need to do that when you have single linear factors like this. You can just take the opposite, negative 4, 3. So your x-intercepts will be negative 4, 3, negative 3, 9, and negative 2. Notice I took the opposites of all these because negative 4 makes that 0. 3 makes that 0. So these numbers make it 0, and if you're plugging an x in, then you're making this whole thing, this whole y 0. Because if this is 0, then the whole thing is 0. Anyway, these are the x-intercepts. And then the y-intercept is you're going to let x equal 0 in all of these problems up there. So like for this first one, if you let x equal 0, you're left with a 4. If you let x equal 0 here, the second one would be a negative 3. If you let x equal 0 in the third one, you get 3. If you let x equal 0 in the fourth one, you're going to get negative 9. And if you let x equal 0 here, you're going to get 2. So basically, whatever all these numbers are multiplied together is your y-intercept. So what is this? I don't know. Maybe we should do this in the calculator. I could probably do this in my head, but we got negative 12 times negative 27. I'm just multiplying a couple of them at a time. Times 2. It's like 648 is the y-intercept. 648 is the y-intercept. Okay? So just for fun, if you wanted to graph something like this, you have zeros at negative 4, 1, 2, 3, 4. Negative 3 and 3. Negative 2 and 9. 4, 5, 6, 7, 8, 9. And then 648 is the y-intercept, so I'd go by like hundreds. 200, 300, 400, 500, 600, 700. So it's like right there. Say we're going 648. Make sure you tell me that you're going by hundreds. And then the end behaviors are here and here. So you just kind of have to go here, 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 and there. So it would look something like that. So you get to hit all your zeros starting down here. You start left. You always go left to right. Start here, hit that first 0, come through, hit the y-intercept. This one's probably one a little bit wide. Come here. And the only thing I don't know is the max and min, so you just kind of estimate. This is just a rough sketch. So if you graphed it, then you would see exactly where these mins and maxes are. It looks something like that. Okay. Okay, so number 11 says, without using a calculator, find the end behavior, maximum number of zeros, and maximum number of turning points of this problem. 5x to the 9th. I don't need any of the other terms. It doesn't matter what else this is, okay, for this question. I only need this first term. So because it's a 9, 9 is odd. 5 is positive, which means that my ends are going to look like this and like that. Okay, so basically on the right, as x goes to the right, its y goes up. That's odd. And as x goes to the left, y goes down, like that. Okay, that's the first part. Second question is, what's the maximum number of zeros? So max number of zeros that you might see is 9. You will match the degree. If that's a 9, your max zeros are 9. Now, that doesn't mean you're going to see this hit the x-intercept 9 times, but you could see it hit 9 times. There could be some double and triple roots in there that maybe that's going to make this number go down, or it could be some imaginary roots, which imaginaries come in evens. So usually your max zeros decrease by 2s, but not always, because sometimes you have double roots and triple roots that mess that up. But that's the max zeros. And the max number of turning points is 1 less than your degree. So in this case, it's 9 minus 1, which means 8 is the maximum number of turning points. Now, what I mean by that is maximum mins. You could have up to 8 maximum mins, but not always, because again, if you have double roots, triple roots, that number could go less. But you could have up to 8 of those. Okay, 12. Use a graphing calculator to find the zeros, turning points, y-intercepts, and end behavior of this. F of x equals x to the 4th minus 5x to the 3rd minus 30x squared plus 40x plus 64. Without even graphing it, if you're looking at the first term here, the highest degree, the degree is 4. And your leading coefficient is 1. So that means your ends, it's going to look something like this on the ends. They're both going to go up. So I can start end behavior right now without even graphing it. End behavior. As x goes to the right, the y is going to go up. As x goes to the left, y is also going to go up. Both ends are going to go up. So that was one thing they wanted. They wanted the y-intercept. I can get the y-intercept right now without looking at the graphing calculator by letting all these x's equal 0. 0, 0, 0, 0. If you cover all these up, you go to the last number. 64 is your y-intercept. Okay, so that's one thing. Y-intercept 64. What else can I do here? Use a graphing to find the zeros, turning points, y-intercepts, and end behavior. So we got the last two. We need turning points and zeros. So we're finding zeros on the calculator, and we're finding our max and mins. Now, max and mins, there could be up to 3 of them, because it's x to the 4th, go 1 less. And zeros, we could see up to 4 of these. Now, if I could factor this, I would, but 5 terms is kind of hard to factor, so we are going to graph to get all this information. So we have x to the 4th minus 5x to the 3rd minus 30x squared plus 40x plus 64. So you guys, everyone got that in? Oh my God, did it again. I swear I do this every time. I'm going to start again. You guys are probably getting mad at me for wasting time here. X to the 4th minus 5x to the 3rd. Right arrow. I always forget that. Minus 30x squared plus 40x plus 64. Okay, graph. I'm on Zoom 6 screen, so if your screen doesn't look like mine, I'm on Zoom 6 screen. Now, obviously you can tell I'm not seeing the max and mins here. I'll change that here in a second. First, I'm going to look at the t-table. I'm going to see if I can see any zeros. Starting. All right. So one of my zeros is negative 4. See it right there? Negative 4, 0. One of them is negative 1. One of them is 2. And one of them is 8. So I could have up to 4 zeros, and I'm seeing 4, so I don't have to do anything fancy on my screen, okay? It's negative 4, negative 1, 2, and 8. So I don't have to use my 0 key to figure that out. I use my T table to do that. Now I do need to see these maxes and mins. So like you cannot even use the max and min key unless you can see them. So let's go to window. Let's change our Y's. We can see all the X's, I just can't see the Y's. So let's go negative 300 to positive 300. Y min negative 300, Y max 300. Let's see if we can see them. I like to start high and then maybe come down. So there's one of my mins. And there's a max. I still can't see this min. So my Y min still has to go lower. So I'm going to go window. So I'm going to go negative 500. Why not just go big, right? So now I'm going negative 500 to 300. So there's a min. There's a max. I still can't see this. Good God, how far can this go? Let's go down to negative 700. Min, max, min. Okay, so now I can see 4 zeros. I can see 3 turning points. Remember, since it was x to the 4th, the most turning points I can see is 3. So there's 1, 2, and 3. Now to find these, we have 2 mins and 1 max. You could press second trace min, number 3. I'm trying to find this one right here. Remember our zeros right here? So I'm going to say that it's between the first two, negative 4, negative 1. So my left bound guess is going to be negative 4. It's one of my zeros. Enter. And then negative 1 is my other 0. Enter. Guess. So one of my mins is negative 2.8. And negative 112. Okay? Negative 2.8 and 112. That's this one. Now to find this max, I would say it's between the zeros, negative 1 and 2, okay? So I use my zeros as my guidelines here. So second trace min, 3. My left bound guess is going to be negative 1, 0. Enter. And then this 0 right here, which is 2. And then I press enter for guess. And my max is 2, 0. That does not sound right. There's no way that's a min. Oh, did I press min? That's why. Sorry, guys. That's a max. 4. Sorry. Let's try this again. Left bound is negative 1. Right guess is 2. Guess. All right, so this is right. 0.59, we'll say 0.6. So max is 0.6 and 76.3. So this first one was a min. My other min is down here, and that's going to be between the zeros 2 and 8. Okay, it's going to be between the zeros 2 and 8. So we're going to go second trace min, 3. My left bound guess is going to be at 2. Now you could use your spider, but I find that tedious. So between 2 and 8. So left bound, press enter. 8 is my right bound guess. Enter. And it's 5.97, so we'll say that is about 6. And negative 560. I didn't really write that good. Negative 560. And those are your mins and maxes. And those are called turning points. Your min maxes are called your turning points. All right. 13. Use a graphing to examine the graphing. Following determine. Okay. So 13a is 1/2 x squared plus 2x. Okay, first question is what's the degree? The degree is 2. Second question, what is the leading coefficient? It is 1/2. The end behavior. End behavior. Since it's squared and positive, both ends are going to go up. So it's going to look like this. Okay, both ends are going to go up. So you say as x goes to the right, y goes up. As x goes to the left, y also goes up. Next question, the maximum number of zeros. The maximum number of zeros, max zeros, would be 2. This number should match your degree. The maximum number of turning points should be 1 less than the degree. So that should be 1 at the most. Now, it doesn't mean there has to be 1, but in this case, it's going to be a min. Okay, it's going to be a min. Turning point, there's 1, and it will be a min. Okay, so that will be a min because both ends are going up. And that's, I don't really need a graphing calculator to look at that, so I'm not going to waste my time punching that in. So the next one, we have x plus 1 squared, and x minus 1 squared. Question number 1, what is the degree? Count your x's, that's 1. This x, there's really 2 of them because it's squared if you FOILed out. So that's 1, 2, 3, 4, 5. So your degree is 5. There's 5 x's. What leading coefficient? If you look at the numbers in front of x, that's 1, 1, and 1. If you multiply all those together, it's a 1. So leading coefficient is 1, which means that your ends are going to look like this. On the right, it's going to go up, and on the left, it's going to go down. So you say, as x goes to the right, the y goes up. As x goes to the left, it's going to be this one, the y goes down. So that's negative. The next question is, that's your ends. Maximum zeros. Max zeros would be 5 because it matches your degree. Turning points would be 4 because it's 1 less than the degree. And that's the only questions they asked. But on this one, you could actually give me a rough estimate on the sketch. This first x is 0. You don't have to do this. But the first x is 0. The next one is the opposite of that is -1, but there's 2 of them. So you go -1 double root. That means it's a bouncy. It just hits it. And the other one would be 1 double root. So even though I said you could have 5 zeros, you only see 3 because 2 of them double up. So it's 2, 3, 4, 5. The y-intercept, if you let x equal 0, since that's out front, is 0. So that's the y-intercept. And we know our ends look like this. So I could give a rough estimate of this. So you go like this. This bounces. It does not go through. So there's 1 turning point. Here's 2 turning points. Go through this one because it's a single root. Bounce, and here. So it looks like 1, 2, 3, 4 turning points. There's your 4 turning points. It looks like I have a max here and a max here. These are my maxes right here. And then my mins are right here. So I could kind of give a rough estimate of that sketch without a calculator. C, x to the third minus x to the second plus 31x plus 40. Again, I do not need a calculator to answer these questions. So question number 1, what's the degree? It's 3. The leading coefficient is 1. So my ends are going to look like this last one. One's up, one's down. As x goes to the right, y goes up. As x goes to the left, y goes down.
I thought there was 2.
There's.
Oh, alright.
Max zeros is 3 because it matches your degree. Max turning points is 2 because it's 1 less than your degree. And that's that one. And then 14, for the function parts A and C, find the domain and range of the function. Zeros, relative min and max, and the intervals of the domain where the function is increasing and decreasing. Good gosh. So we're going to come up here, back up to 15. Can you give me 1 second? I'm going to finish these 2 problems and I'll be with you. Get your stuff out that you need help with. So it looks like I am going to be graphing this now. So we're going to come up here. We're going to say 1/2. I'm just going to say 0.5. X squared plus 2x and graph. Oops, I'm still on that one screen. If you press on, it stops your graph in the motion. Press zoom 6. So there's the thing. Remember, they want the zeros. It looks like the zeros, we can look at the t-table to find those, would be 0 and -4. So if we come back up here to number 14, for A, the zeros are -4 and 0. What else do they want to know here? Find the domain and range. Well, this graph, if you look at the graph, your domain is all real numbers, but your range stops at this vertex right here. So we're gonna go ahead and find this min because that's important to your range. So to find your min, press second trace min. Yeah, that's on my video. You can do the spider. I'm doing the spider right now. Press enter. Press enter. Enter. And it's -2, -2. So the min is -2, -2. So when I'm doing domain and range, domain is all real numbers. But the range, the lowest point it goes from this y right here, is -2 up to infinity. That's your range. And then the intervals where it's increasing and decreasing. It's decreasing on this side and increasing on this side. So you would say it's decreasing from, now it's coming up, you start from here. It's positive infinity to this number right here, this x, which is -2. That's the x of the min. This is the x coordinate of your min. It's increasing on the other side of this x coordinate. So you'd say it's increasing from -2 back up to infinity. All right, I'm going to have to stop here because I have people coming in for help. So we'll have to go over the rest of it in class.